Welcome back to the channel. Obviously I'm not in my shop today. I'm down here at the Glen Meadow and Orchard Railroad. Now this is home of the Lakeshore Live Steamers. The railroad itself is located at the Penitentiary Glen Metro Parks. It's part of the Lake County Metro Parks in Lake County, Ohio, and we're in Kirtland Hills, Ohio. So we got a bunch of track here down at the railroad, and it's our club railroad, and we bring our locomotives and stuff like that down here to run them around the track, have a little bit of kid fun as grown-ups. But about once a month or so, we also do some public runs where we give free train rides to the public. And I've shown some of that video on my channel before. Right now, I don't own any railroad equipment that will run on these tracks, and I'm hoping to change that. And that's really what this video is kind of all about. It's an introduction to a project that I'm starting. I don't know how much of it I'm going to show on the channel, but I did want to share what I'm up to, and that's kind of really what my channel has always been about. It's not a how-to channel. It's this is what I did and this is what happened. And this is what I'm going to be working on. But before we get to it, I just kind of want to show you around a little bit of the railroad and an idea of what I'm going to be building. This is one of the locomotives that's owned by the club. It's modeled after a GP38. Now, I'm trained to operate this one, and I even engineer it on our public run days. And I really like this one. I like diesel locomotives, and if any of you ever watched Blondie Hack's YouTube channel, she's currently building a steam locomotive that's about half the scale of these. And you can see the level of effort that she's putting into building that. It's quite monumental. And I don't know that I have the expertise or the competence really as a machinist to build something like that. So I'm going to kind of hold off on that project for a little while. But I would like to build a diesel locomotive similar to this one. Now this one is powered by a gasoline engine, and I think I'd rather have mine powered by battery. It's a lot quieter, I can add sound to it, and it's just a simple recharge. And the battery technology today, those things will run for 4, 5, 6 hours on a single battery charge. The locomotive that I want to build is going to be very similar to this one. It's got some slight differences and some details, which really aren't all that important. But I was able to locate some plans for a GP40, which is just a slightly different variation of this locomotive. The plans are designed so that all the metal can be cut out with a laser cutter or a plasma cutter. So I'm going to head back home and I'll bring up the design on the computer, and hopefully that'll give you a little bit of an idea of what I'm going to build. As I mentioned, when I was down at the railroad, I came across a YouTube video of this guy from JT Engineering where he built a 1.6-inch scale GP40 using laser cut steel. He did all of the designing and was offering this as, a bit of a DIY kit. And you can go on his website and you can purchase the DXF files along with the 3D models for the details, the headlight, the class lights, the number boards, the fans, and the shrouds. And I know that there are some that would rather have those as metal, but honestly, for my uses, I think this is going to work fine. And watching his video on him welding this stuff together seemed like a project that, this wouldn't be too difficult to take on, at least the construction of it. We're not getting into all of the electronics just yet, but the construction of it seemed like it was something that I could handle. The files come as a downloadable zip file, and inside that zip file are a materials list, a printing guide, all of the DXF files for the laser cut steel, even some instructions on, if you're going to use dynamic brakes or not dynamic brakes, which files to choose from. Same thing with the floor sheets. If you're going to use the AccuCraft trucks, or you can get one that's a blank floor sheet. Even the panels, you can get them with cutouts for the doors, and you can get them with it plain. So then there's another folder here for the STLs. These are all of the 3D models that you can use with any 3D printer, whether that be a filament or a resin printer. Most of this is probably best suited for a filament printer. And there's even some stuff in here for the acrylic, so some layout for the windows. I took the DXF files that I acquired from JT Engineering, and I ended up recreating the model of the GP40 in Fusion 360. This was a considerable undertaking, but wasn't impossible. And this really kind of gave me a chance to kind of see how it all goes together. Now, the video on JT Engineering's YouTube channel does tell a lot of the story, but I don't know, I guess I'm more of a visual learner than anything. And this also gave me an opportunity to make some minor changes. First, talk a little bit about the model here. Again, this is just importing the DXF files into Fusion 360 and arranging them how they need to be arranged, setting some joints and stuff like that to hopefully keep it in line. I did happen to come across a model of a GP38, which also uses a Blomberg truck, which is what you see here. So I wanted to see what it looked like with the trucks in place. Some other modifications that I made was to the coupler, the front coupler. I wanted this to match a little bit more to what Burlington Route used on the front of their GP40. And I added 2 different connections for safety chains. All of the rail cars at Lakeshore Live Steamers uses a pair of safety chains, so I figured I'll just build those in. I also made just a couple of simple changes to the stairs. I felt the spacing on the original one could be improved, and so I did there. Also, on the number boards, of course, I redid the number boards for the number of the locomotive that I am modeling. I also redid the upper headlight to have the little light shield that's on the prototype. Wasn't really necessary, but I wanted to add it. And I've got some idea of how I can capture these lights in the nose and the headlight to avoid needing to use any kind of an adhesive, although I'm not opposed to using an adhesive at all. That was really about it. Everything else is pretty much as it was designed. Of course, Fusion's having a fit here. The coupler pocket back there is missing. We won't worry about that. This is, colorized by object, part of Fusion. It normally would come out looking like this. And this makes it a little bit difficult to see, what you're looking at. So I'll go back to the color version. And that's really kind of about it. Now, this model does not come in the package with the files from JT Engineering. I did this on my own. I'm unable to share this or any of the files because they are licensed from JT Engineering, so I won't be able to help anybody out with that if you were thinking about asking. The only other change I made to the model was to the floor plate. I wanted the extra weight, so instead of using the as designed 12 gauge, I went to 1/4 inch. So this is going to be a 1/4 inch floor plate. Makes it a little bit heavier, but I'm okay with that. Now, after making these changes, I couldn't use the original DXF file, so I had to recreate those using Fusion 360. Most of them were identical. Most of the files were absolutely identical. There was just some minor changes, again, to the way the front pilot, the way the coupler pockets are functioning. So I had to export all brand new DXF files and then find a laser cutter that would do this work. Now, there are some online places out there. Oshcut is what JT Engineering used. Send Cut Send. They do not have the ability to do these longer lengths. The trouble with Oshcut, they're out in Utah and I'm in Ohio, and the freight shipping charges would have been like $1,000 to my door. Now, there probably could have been some other options, like delivering to a terminal and stuff like that. And I know Oshcut was willing to work with me a little bit. However, I was hoping to find a local business that I could support. So I sent a number of emails out to several local businesses and found one that was only within 20 minutes driving distance from me that was willing and able to take on this project.
All right, well, my name is George Blankenship. This is Metal Fabrication Technologies. We're in Chardon, Ohio. We started as a family business back in 2021. We started as a products company. We've slowly grown to add equipment. We recently added this laser cutter behind me 2 years ago. We do all sorts of work, anywhere from jobs for large corporations to small jobs for small fabricator shops in our area. We have 6 full-time employees at the moment. We're actually actively engaged in finding more employees. We're off to a really good start for the year. Hopefully we can keep that momentum going. We're always eager to bring on more work. This is a Mitsubishi laser. It's a 6 kilowatt laser. We're going to do 5 foot by 10 foot material. We can do anywhere between 22 gauge up to 1 inch thick steel and up to ½ inch stainless and aluminum.
Okay.
We can run off of compressed air, nitrogen, oxygen for the cutting distance gases.
So when the laser is running, it's not just the laser, there's something else going on in there too?
Oh, there's a lot going on inside there with the laser running. So the device that creates the beam, this is a fiber laser. So basically the beam falls through like a fiber optic cable, essentially. And when the beam comes out of the nozzle up top, there's lenses that focus the beam depending on the thickness of your material. And then around the beam, there's a bunch of different gases depending on what you're cutting to make sure that the material that is melting away gets blown through the bottom of the material.
Okay.
And that's what allows you to separate
All the dross.
Started with a small plasma table, but the quality of cut was not what we needed for our parts. This right here is the program we're going to run. There's approximately 160 different pieces on here. The parts are nesting software. Put parts inside of even the remnants that'll be basically would have been lost material and still try to reutilize that material for other components. Another cool thing about this laser is it's got basically like a alternate reality mode where we take a picture of what's in the laser and then we can take our program and drag and drop it anywhere we want to start it.
So there's 160 some parts on here. How long will this actually take to cut?
The estimated time, I believe, was 25 minutes. This thing can approach speeds of 1,000 inches a minute. So what it's doing right now is it's automatically changing the nozzle for the material type that we selected. Here's with the material.
Still bright even through the tinted. I find it fascinating, the order of operations here. It's like, I understand you got to do the holes first, right? Because if it shifts at all, but why it picks one thing over another. Now it looks like that piece warped a little bit. Is that going to cause a problem, or does it lift up enough?
There should be enough spacing between the parts. We'll find out here soon.
Will it sense that, or is it going to crash?
Once the laser was finished cutting out all of the parts, the machine automatically swaps the table with the one on standby, and now it's a matter of going over the sheet and just picking all of the parts off of it. There are tabs that are left in place on a number of the parts, and all you have to do is just kind of twist it, and it just pops right off of the parent piece. So actually pretty straightforward. This thing did a lot of interesting nesting, where it placed parts inside of other parts that had holes cut out. It was rather efficient, and just about every single part of the locomotive fit on this 5 by 10 foot sheet of 12 gauge steel.
So somewhere on this pallet is a GP40 locomotive. Well, here's all of the pieces from the laser cutter for the locomotive sitting on top of this crate. So my next task really is I need to take all of this stuff off of the crate. I'll probably just put it back into the back of my truck temporarily, because what's in the crate is a motorcycle lift. And that's what I'm going to use to build the locomotive on. That'll give me the ability to raise it up and lower it down when necessary. And it will likely end up being the place, at least for now, where I store the locomotive, between storing it here and taking it to the railroad down at the park. So yeah, this stuff's pretty heavy. Also in this brown box is a set of 6-inch casters that I want to put on the lift to make it a little bit easier to move it around here in the garage. So I'm not sure if I'm just going to weld those on or if I'm going to screw holes and mount them. I need to get this thing out of the crate first and see what I'm working with before I can even do that. So right now I need to move this thing out of the way. Luckily I put it on furniture dollies. It is fairly simple to move, although again it ain't light either. So let me get this out of the way, get this small stuff at least in the back of the truck. The big floor plate I'll probably just lean up against the Jeep because that's still here, and that's what it's sitting in front of. At some point this Jeep's going to go away because I think I'm selling it this year, which is going to be a little weird because my channel got started because of this Jeep. But all good things must come to an end, and that's what the Jeep is. So who knows, maybe somewhere on this locomotive there might be some indication that this is the new Little Mule. I don't know what I'm going to do yet, but I do know I need to get started on this. I don't know the timeline that this is going to take. You can hear I got the garage door open, which is why you're probably hearing some traffic. It's kind of a cool spring day and I'm taking advantage of that. All right, let me get this stuff off of here so I can start uncrating this lift. Okay, we got all that off of there now, so let's get this thing open and figure out what we're dealing with. Honestly, don't know how assembled or disassembled this thing comes, so. Is that the only thing holding this lid on? Yep. Alright, well, these are the stock wheels that came with this, and that's just not going to work. I really want to use a nice big swivel, but mount is not going to work because it's going to hit that. So I need to raise this up at least to the level of that. I don't want to put them there because I think that'll be too far inbound and create a situation where it could be top heavy. So what I really need to do is raise this platform up. Or I've got this scrap C-channel. I mean even if I welded it right onto that platform, is that going to be high enough? Be barely high enough for that to swivel around, which is all I really need. I just need it to be barely high enough. Worst case scenario, I could shim that up a little bit. So that'll work for these sides. I think I could still use this for the front. So on this end, it's just these cast iron wheels. But I think I can weld this right to that. And then that go right on top of it. That means I don't have to cut anything off of this lift. Not that that matters. I mean, once I start welding on it, pretty sure I avoided the warranty. But now I just need to go ahead and take this piece and cut it down into 4 pieces. Might as well make them all the same. So let me get this measured up. I'll cut this out on the bandsaw. Okay, I got these cut. They're reasonably square. Now what I need to do, I need to mark on here just where I need to start removing some paint. Okay, I think I'm all set up for welding here now. I've got my Prime Weld MIG 285 set up here. This is, I'm setting up for about 1/4 inch. I think it might be a little bit hot, but I think we'll get it tacked in and probably reduce this down a little bit. This material is kind of thick, especially in the corners. I could probably go a 3/16 setting and be okay. I think I might do that anyway. So 3/16, according to the chart, is going to be 20.8 volts and 354 inches per minute. And we'll see how that goes, and we'll make adjustments as necessary. Just going to try to get this tacked in place first on all of these, and then come back and finish weld them. After that, I just want to kind of get this lined up here so it's right on the front and flat. This welding helmet is not the most comfortable. It's an Arc Captain. The batteries are still dead in my Miller Elite. I'm actually thinking about getting a new helmet, but it's a lot of money, so I've been kind of holding off on that. I got that one tacked in. I'm going to go ahead and prep the other 3 legs, platens, whatever you want to call it. And I think when this is sitting on top of here, it's going to be just barely big enough. And I'm thinking I might just weld those in place rather than go through the hassle of drilling holes. If I have to remove it, it's not that big a deal. I can cut the welds. All right, I'm going to get the other ones cleaned up and get them prepped and tacked on. And I'll bring you back when I'm ready to weld this one out. All right, I got these tacked in place. Not sure they're perfectly flat. I think this one right here is a little tweaked up. I don't know if that's going to matter. The purpose of this thing is to make it easy for me to build this locomotive. Not to be a showpiece, however, it needs to be steady if I got to shim it up. That's the downside of, I guess, of welding these wheels on rather. To be honest, I really don't want to go through drilling holes, so we're going to weld them on. So for now, let me get the rest of these, or get these welded out now. So they are permanently attached. I'll weld down the front here, crossed, and inside. When I turn it over, I should be able to get the inside of these, but I'm not going to be able to get the inside of those. I might end up welding a piece of that out from that outrigger onto the C channel just to give it some more strength, but I think we'll cross that bridge when I come to it. Once I get it flipped over and get the table up in the air. That could probably be hotter. 22.5, 402 inches per minute is by the book for 1/4 inch. I think that might be a better setting here. Oh, this Arc Captain welding helmet just won't stay on my head. I miss my Miller. No, that ain't right either. It don't sound right. It don't look right. Maybe I got it too hot. So how about 18 volts, 263 inches? Good thing these welds are on the bottom. No one will see them. Well, that sounded a little bit better and looks a little bit better too, but it ain't perfect. I think it could be better. I'm gonna slow down the wire feed and go back over to this first part, get a better weld on it, because I don't think I got both edges. Now that sounded a ton better and looks a ton better, so we're gonna roll with that. That's going to have to do. When I flip it back over, it might be a little bit easier. That should be good. All right, I'll go around and do the other 3. I'll bring it back when I'm ready to flip this thing. Alrighty, next step on this is to get it flipped over. Move that over to the side, that might help. Nice and easy. There we go. Well, I think this thing is going to work out fantastic for building the locomotive. As you can see here, I've got a lot of the laser cut parts here kind of organized and grouped. It's been a couple of weeks since I got this, so there is some surface rust appearing on some of this, but that's not too big of a deal. I also picked up a set of couplers from a company called Accutie. These are actually plastic with a rubber buffer, and I understand from a friend that these are very nice couplers. They're durable, even though they are plastic and not the cast steel, but they're also about a third of the price of the ones that are cast steel. And these have this little rubber section here that adds a little cushion to it. I've also been busy doing some 3D printing. In this box here are a bunch of parts that I've been working on for the locomotive. We've got some, these are printed out of ASA material and will get screwed to the side of the locomotive. We got, radiator, fans, we've got the fans, and fans and the shrouds. Those will go on the top of the locomotive. And then for the parts that I think needed a little bit of extra attention to detail, I used a resin 3D printer to print these. Got an Elegoo Labs Saturn 4. This is the rear rear light. This is the front light. This is another front. This goes on the front of the nose. Now these will get lit using these LEDs on these little star PCBs. And I also printed some, this is filament printed out of PLA. This is going to be used to sort of capture the lights between the pieces of steel. We'll see how that works out. Let's see, what else do we got in here? We got window frames. We've got horns, a bunch of these stanchions. These will be used for the handrails. I also printed number boards. I'm missing the black oval in the center of the 0 is down in here somewhere. But that's going to be lit. That was printed with a translucent material that'll get lit from behind. Let's see, what else do we have in here? Rear number boards. We've got the bell. This will eventually get painted. Down here, I've got a slew of these door latches. I wanted to do these with resin print because I think it really brings out the detail better. And these will fit and be epoxied into the doors. There's quite a few of them. I think I have probably 70 or something like that in there. And that'll be a nice detail. I still have to figure out what I want to do for the hinges. I'm thinking I'm going to design something up and resin print those as well. Oh, and for the lights, I did find these lenses, and these lenses will go inside of the headlight housing to kind of give it a more realistic look, and also to spread the light out a little bit. I do have different lenses for the headlights and for the classification lights. Well, I think that's going to do it for this video, this introduction to an aspect of a hobby that I'm hoping I can enjoy for many years to come. I wanted to show just a little bit of what it took to design and get all this material laser cut, and also to thank the company that did this for me. I paid full price for all of it. There was no sponsorship there involved. They were just interested because they thought it was a cool project, and I appreciate George for doing that. The next step for this really is I got to figure out a few things. Number one is this is going to be an all-electric locomotive, so I've got to really figure out what those motors are going to look like. And there's a number of different configurations that you can do with these things. I'm leaning toward the ones where the motors are directly on the axles for each wheel set. They are pretty expensive, though, to go that route. But I think it would provide more power and be a little bit easier. Battery technology is another thing. I'm looking at something like lithium iron phosphate LiFePO batteries. They got a great life on them, and since it's not something that's going to be used every day or necessarily every week, I think they'll last a lot longer. The downside with a LiFePO, though, is they are 3 times the cost of a lead acid battery, but they're only a third of the weight. And you might think that having that weight savings would be great, but that's actually a negative. I want this thing to be about 650 pounds. That will give me the tractive effort that I need in order to pull a train that's got 8 or 10 adults behind it. So I still have to figure all that out. I also have to figure out what I'm going to use for motor controllers. I'd like to put the sound system in it, so adding all those little nerdy things that train guys like to do. I haven't figured that out. I might just build my own from like a Raspberry Pi or an Arduino and go from there. I've got an air brake system I've got to manage, and this is not the only thing I need to build. I also need to build a car that I sit on to control this one. So it's called an engineer's riding car, and it sits right behind the locomotive. I want to build one of my own, put in a air brake system with a compressor, etc., to control the air brakes on the rest of the train. That's a safety feature that I will not do without. That being said, I don't know how much of this I'm going to show on my regular channel because the algorithm hates it when you have too many different topics, unless you're like a Mr. Beast or one of those guys that just does weird things all the time. My channel is mostly about vintage machine restoration and using them, and this really doesn't apply to most of what I'm doing here. So I think I'm going to have the majority of the content for this either on my Patreon page or the YouTube members only, the channel members, and we'll leave it at that. I think maybe when there's something a little bit more interesting, maybe when there's some machining involved, I'll bring it over here to the regular channel. But if you'd like to see this kind of content on the main channel, give me a comment down below. Of course, thumbs ups are always appreciated. If you're not a subscriber to the channel and you want to support the channel, hit that subscribe button. It helps the algorithm, helps Google know that people like this channel, and they're more likely to recommend it to others if they see that. If you'd like to support the channel in other ways, there's some links down in the description that'll tell you how to do that. Well, that's it for this one. Thanks for watching, and I'll see you on the next one.